Alright, so here we go with properties of parallelograms. So we're going to prove and apply properties of parallelograms in this, and then we're also going to use those properties to solve some problems. Alright, so taking in our first definition here, I'm sure you've all seen a parallelogram and had ideas of it, but our official definition is a parallelogram is a quadrilateral, meaning 4 sides, with 2 pairs of parallel sides. So as you can see in the diagram, we've got our tick mark here and here, meaning the left side and the right side are parallel. And then we've also got the tick mark here and here, saying the top and bottom are parallel. So to write the name of a parallelogram, it turns out you can just use an image of a parallelogram, just as we've done triangle ABC. We can now do parallelogram, ABCD, because of course there would be 4 vertices. Alright, and again, given here, you can see that AB is said to be parallel to CD, and then also BC and DA. Our official kind of theorem, if you will, is that if there's a quadrilateral, and that quadrilateral has been said to be a parallelogram, then its opposite sides are congruent. So we know by the definition of a quadrilateral, a parallelogram, which is why it's called a parallelogram, because of the parallel sides, opposite sides are parallel. Alright. So, in our next idea here, we're going to go through 3 other properties that happen to then make parallelograms. So, turns out if a quadrilateral is a parallelogram, then its opposite angles are congruent. So that is also an idea that could happen. So you will automatically have a parallelogram even if you don't have parallel sides, because if opposite angles are congruent, then you know that you actually make parallel sides. So opposite angles can be congruent and make a parallelogram. We've also got the next one. If it's a parallelogram, then its consecutive angles are supplementary. So remember, that means that this one plus this one, consecutive, because if you think of the alphabet, B and C are next to each other, are going to equal 180. Okay. And then the last one is if a quadrilateral is a parallelogram, then its diagonals bisect each other. So that's an interesting one. That means this piece and this piece are the same length, and this piece and this piece are the same length. So, diagonals could bisect, consecutive angles could be supplementary, opposite angles could be congruent, or, by definition, the opposite sides could be parallel. So there's 4 ways of knowing if something is a parallelogram. Alright, so in number 1, they're telling you it's a parallelogram. We've got C, D, E, F. So because we know it's a parallelogram, it can have all of these properties, so we can use them now that we know it's a parallelogram. So, one piece that's given is that DE is 74, so DE. We're also given that DG is 31, and that the measure of FCD, where's F to C to D, so this whole thing here, is 42 degrees. And we want to find CF, at least to begin with. So where's CF? That's this one. Alright. And I'm sorry because I missed a tiny piece over here. By the definition, we have parallel sides. But by this first property, we actually have opposite sides that are congruent. So there are 5 ideas. So, of course, that moves on to this one, where if we're trying to find CF, we know that opposite sides are congruent as well as parallel. And so CF is going to equal DE, which equals 74. Alright, the next one is EFC. So EFC, this angle here. Okay, and it turns out that consecutive angles our supplementary. And so that means that angle C plus angle F was supposed to be 180 degrees. But of course, angle C is angle FCD. And so that's going to be added to angle EFC to be 180. But FCD is 42 degrees. And so we need to take away the 42. And so we get that angle EFC is 138 degrees. Alright, and then the last one is DF. So that's the entire length. And so we know that that's happening because diagonals bisect each other. And so we know that DG plus GF is going to equal DF, which is what we want. But DG is 31. And because DG equals GF from it being bisected, we can add 31 plus 31 to equal DF, which means it's 62. Alright, so again, because it was said to be a parallelogram, we have all of these 5 ideas that we can work from. Alright, next one here, again, it says it's a parallelogram, so we can use those 5 ideas. So, we are going to find YZ, and YZ is over here. And of course it's the same length and parallel to this one over here. And so because it's the same length, we know that YZ equals WX. And again, that's because opposite sides are congruent in a parallelogram. So that actually means algebraically that 8a minus 4 is going to equal 6a plus 10. So to solve, we're going to put our a's together. Put our numbers together. And get an a of 7. Of course, that's not the answer. That just means that I need to put it in to get 8 times 7 minus 4, meaning 56 minus 4, or 52. So YZ is 52. The other one that they want you to find is Z. And of course that means that angle W and angle Z, since they are consecutive, are supplementary. So that means that angle W plus angle Z should be 180 degrees, or 18b's minus 11 plus 9b's plus 2 should equal 180. Or if we put like terms together, we've got 27b's minus 9 is going to equal 180. Solve by adding, and we get a b. So 189 divided by 27 of 7. And so plugging that back in to find z, we're going to have 9 times 7 plus 2, so 63 plus 2, which is 65 degrees. Alright. So the next ones here are interesting. We've got 3 vertices of JKLM, and we need to find the coordinates of M. So the interesting part about naming a parallelogram is that you actually do it in circular order. So for instance, if we imagine this kind of going in a circle, if this name is JKLM, we start at J and go to K and then go to L and then potentially M, which would be over here somewhere. So you're always kind of moving in this circular way around a shape. So you would never name a shape JKLM in that order, because it's not going in the circle of J to then K to L and then M. So because of that, we know that our M dot is going to be somewhere over here. Okay. And so in order to get that, we would have to understand that the sides are opposite and congruent, the sides are parallel, lots of things happening. So for instance, if this side is going to be parallel to this side, I would need it to form kind of that same pattern. So it looks like it goes up 1, 2, 3, 4, and over 1, 2, 3, 4. So in order to get from J to M, I'm going to need to go up 4 and over 4. So it looks like my dot is going to be right there. The rest of the shape is going to fill in kind of like this. And so we know that our coordinate is 7, -3. And actually, I drew that a tiny bit off because I went up 3 instead of 4. 1, 2, 3, 4. It's right here. So because of that, this is actually -4 and 7. And actually not, oh wait, 3 plus 4, yeah, 7. Okay, sweet. So the vertex is 7, -4. The interesting part about this is, depending on how you looked at it, you could have also had M kind of over here, because this is also a parallelogram, right? But again, because of the way that it's named, you can't have it KLJM. Like, that's not how it's named. So we do want to make sure that that M comes after that L. All right. So then we have our last one, which again is finding that last piece. So PQRS, meaning P to Q to R to S. So that means that R is going to have to be in here somewhere, because we do want it to follow in that order. So P to Q to R to S. And so taking a look at how this is formed, if I want to make the parallelogram so that R is kind of up here, I need to go from P up 1, 2, 3, 4, 5, 6, and over 2. And so in order to get to the next one, I'd need to go up 6 from 0 and over 2. And so that means that the coordinate of R is going to be 7, 6. Alright. And again, it could have been a shape that ended up being down here, because that's also a parallelogram. But again, because of the order of the letters, we needed to make sure that we would find R up here, so that it could be P, Q, R, and then S. Alright, so that is our set of notes for 6.2. So hopefully we have all 5 of those properties. Remember, the properties of a parallelogram are, by definition, the sides are opposite and parallel. The opposite sides are congruent, as well as opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. So all 5 of those things happen.